Hello everyone. A very good evening to one and all present here. It is a great pleasure for me to welcome you all to the 11th edition of Alumni Research Talks organized by the Computer Science Association of Bitspalani. CSA is the department association for the Department of Computer Science. CSA stands as a powerful learning platform with substantial inflow of guidance and mentorship for seniors. The association has an open nature, thus allowing the convergence of computer science enthusiasts from all streams of study. CSA is noted for organizing quizzing and coding events around the year. Innovative events such as anti-coding and capture the flag during Apogee, as well as the ART. The first edition of ART was held in 2012, and after its tremendous success, it has been continued as an annual event. Our second speaker this time is Aakanksha Naik. Aakanksha is a PhD candidate in the Language Technologies Institute at the School of Computer Science as CMU. Her current research tackles the task of developing event extractors for medical data with no in-domain training. Transfer learning research has improved the generalization ability of models trained in NLU benchmarks, but an important issue plaguing long-tail domains such as clinical text with data scarcity. How far can transfer learning improve performance on long-tail domains in low data regimes? Join us in the talk, adapting information extractors to long-tail domains as C unravels the solution to this and many such topics. Akansha, you can take the stage.
Thank you so much for the introduction. I guess you guys can see my slides in present mode right now. Okay. Hi everyone. I'm really excited to be here and to give this talk at the Alumni Research Talks in Pilani. Sort of feels like I'm coming back to campus after a long time, even if only virtual. As Rohan mentioned, for the first 45 minutes or so, I'll be talking about my research on adapting information extractors to long tail domains. And at the end, I'll take a sort of detour and talk about the graduate admissions process. And if you guys have any questions at the time, you can feel free to ask me. Unfortunately, I can't really see the chat right now while I'm presenting, so I'll just take all of the questions at the end, but feel free to drop them in the chat during the talk. So let's begin. Before I start discussing my work, I want to just briefly talk about the long tail in language processing, where it arises from, and what conceptualization we are going to use for it throughout this talk. So the long tail primarily arises from the focus on benchmark-based model development and evaluation in natural language processing, a paradigm that began with the construction of the pen tree bank and led to a focus on building models to tackle the phenomena that are most central or most frequent in naturally occurring text. And coupled with this focus of benchmark based paradigms on central or frequent phenomena, in addition with the Zipfian nature of language, this causes lots and lots of domains and phenomena that are low frequency or low resource to be left out of traditional benchmarks or be underrepresented in them. And this is what I'm calling the long tail. Um, Throughout this talk, I'll basically be using a two-level conceptualization of the long tail. The first level conceptualization is looking at it from a macro view. That is, given all of the texts that fall into the long tail, they can be grouped into various categories based on broad dimensions of linguistic variation, which could be things like what language is the text written in, what is the register, domain, genre, style, etc. So, as an example, if we were to cut up the long tail into pieces based on domain, it could look something like this, where we have clinical narratives, clinical conversations, literary texts, etc. Um, and an alternate view, which is the second level view for the long tail, is a micro view where instead of looking at text from the perspective of some broad overall dimension of variation, we group it into categories based on the presence or absence of specific linguistic phenomena in the text. And this could include syntactic phenomena like negation, pragmatic phenomena like deixis, semantic phenomena like causality at various levels of language. And this is what a sample division by phenomenon might look like. And obviously, these two views of the long tail macro and micro are not fully disjoint, but they are deeply interconnected. And Oftentimes, a lot of domains that fall into the long tail at the macro level contain higher proportions of linguistic phenomena that fall into the long tail at the micro level. So, for example, if we take the case of clinical narratives and negation, even though negation is not a very common phenomenon in typical texts like Newswire, in clinical narratives, you can see nearly 50% of entities being negated, which is a really high proportion. So, oftentimes, what we can do is expand the space of domains that we are studying, and this will end up bringing more and more linguistic phenomena from the micro long tail into our purview. So, given the existence of this long tail and this two level conceptualization, this raises three key research questions regarding the applicability of adaptation methods for long tail domains. The first one is what adaptation methods work best for adaptation between various macro level dimensions. The second question is what practices or what methods work best when we are trying to do this adaptation at the micro level for various linguistic phenomena. And the third question is what are best practices to accurately evaluate the performance of models on these kinds of long tail domains and phenomena. And I've done work in each of these three areas, but for today, the primary focus is on identifying best practices for adaptation at the macro level. And my goal throughout this talk is to sort of go through a series of case studies and show how you can build up a set of best practices that facilitate informed selection of transfer learning methods when you have a new long tail domain or a new long tail setting. And throughout all of the case studies that I'll be presenting today, there are three key principles that we try to stick to. The first one is to make sure that whether we are proposing a new method or evaluating existing methods, we cover a broad range of categories. And what I mean by categories will become clear in a few slides when we are selecting adaptation methods to compare. The second principle is to not just look at overall model performance, but also go beyond that and do extensive qualitative and quantitative analyses as follow up in order to understand better how model abilities relate to various properties of data sets and what makes certain models perform better. And finally, the third principle is if even if we identify negative results, they can be used as a way to sort of identify potential performance limits for the adaptation methods that we are looking at, which is also a useful result in and of itself. So, before we jump into the case studies, I want to just briefly give an overview of various kinds of methods in the field of domain adaptation and transfer learning and how we can categorize them into a taxonomy. So, this taxonomy is sort of an extension of prior work by Ramponi and Planck, who proposed a taxonomy for adaptation methods that were both neural and unsupervised, but we had to extend it a little bit to also incorporate pre neural methods as well as adaptation methods that can work in supervised settings. So, at the first level, broadly adaptation methods are divided into three different categories: model centric, data centric, and hybrid. So, model centric methods are ones where the adaptation method modifies some part of the model to make it better on the target domain. The data centric methods are ones where methods manipulate the data distribution in some way to make it perform better on the target domain. And hybrid methods are ones which can't clearly be classified as either model or data centric. Under the model-centric category, we have four more subcategories: feature-centric, parameter-centric, loss-centric, and ensembling methods. So feature-centric methods are ones where, like as is maybe sort of clear from the name, you're editing the feature space of the model in some way to do adaptation. And this includes categories like feature generalization, in which you learn a joint feature space for both the source and target domains using methods like autoencoders. And method categories like feature augmentation, where you're adding an additional target specific feature space and learning weights for those. The second set of methods under model centric is parameter centric methods, where you are making some kinds of edits to the model parameters in order to make it perform better on the target domain. And this includes three subcategories: parameter initialization, where what you sometimes do is train a model on a related task or domain and then initialize the parameters of the current model using those weights; parameter addition, where given a model, you try to introduce a small number of extra parameters at different stages in the model and only fine tune them for the target domain; and then parameter freezing, which works by freezing weights in different parts of the model in order to prevent overfitting, which has the side effect of improving generalization. And then there are loss centric methods, under which the primary category is loss augmentation. Loss augmentation is probably one of the categories that a lot of you might be familiar with because it includes things like multitasking, so jointly training a model on multiple different tasks and combining their losses, or even using additional loss terms to act as regularizers to improve generalization. And finally, the fourth subcategory of methods under model centric is ensembling methods. These are sort of rarely used in literature. They are more commonly used in settings when you have multiple source domains that you can learn from in order to adapt to a new target domain. And these methods work by learning things like mixture of experts over all of the source domains that you have available. Under the data centric category, there are five different subcategories. The first one is pseudo labeling, in which the main goal of the method is to generate labels for a large amount of unlabeled target domain text. And they do this either by using external knowledge sources, heuristics, which is the set of distance supervision methods, or by training a model on a source domain and using it to generate labels for a bunch of target domain examples, which is what self training typically does. The second category of methods is active learning, which is also a category I'll be touching upon later in this talk. And active learning methods work by selecting a small subsample of methods from the subsample of instances from the target domain. And these instances are selected in such a way that they are most informative and can improve the performance of the model best. The third category of methods under under data centric methods are instance learning methods, which is a really interesting class of methods. The way they work is they again try to learn a joint space for both the source and target domains. But once you've learned this joint space, for every instance in your target data, you look at what source domain instances are near it and then try to make some prediction for the target data based on the labels of its surrounding source instances. The fourth category under data centric methods are noising and denoising methods. And the way these work is you either add extra noise to the source data or remove noise from the source domain in order to make it look lexically or at some other level more similar to the target domain. And finally, pre training, which has sort of taken the NLP world by storm recently and involves training really large scale language models which learn better representations for the source and target domains through this process. Under hybrid methods, there are two subcategories, instance weighting and data selection. And both of these methods work by learning some kind of an alignment function between the source domain instances and the target domain instances, and using this alignment function to upweight instances from the source domain that look more like the target, or to filter out instances from the source domain that look less like the target data. And as an example of where some methods would fall in this taxonomy, if we consider the adversarial domain adaptation method, again, a method that I'll be covering later on in more detail, it falls under the loss augmentation category under model centric methods. So, in addition to identifying this kind of a taxonomy of adaptation methods, we also wanted to look at what are the methods that have been used most popularly in literature. So, what we did was we did a qualitative meta analysis of 100 papers on the topic of domain adaptation and transfer learning that have been published in recent years in star CL conferences. So, when we selected these 100 papers, we went through all of them and looked at what methods were applied or proposed by these different papers. And we annotated all of those methods for what were the course categories that they belong to and what were the fine categories that they belong to, which are the leaves in our taxonomy. And this is the distribution of course categories over all those 100 papers. And as you can see, model centric methods are the most popular, followed by data centric methods. And if you break it down by fine categories, which are the lowest level in our taxonomy, you can see that the most popular methods are feature augmentation, loss augmentation, and pre training has started to pick up steam in recent years. So, based on these different popular categories of methods, we decided to focus on these for the rest of the experiments. This is just a very simple and helpful visualizer in order for you to keep track of where we are currently during the talk. So, Given that we are looking at a bunch of different macro dimensions and a bunch of different adaptation methods, you can visualize the space of possible experiments as a two-dimensional matrix where all of your rows are the different method categories that you're looking at, and all of your columns are the different macro dimensions that you're looking at. And in our case, for the rest of the talk, I will be only focusing on the dimension of difference in domain. And specifically, I'll be focusing on three different domains: clinical narratives, clinical conversations, and literary texts. And as I mentioned before, because they are used most popularly, I'll begin with a focus on feature augmentation, loss augmentation, and pre training methods. First in an unsupervised setting, and then as we move to a limited supervision setting where we are allowed to have some access to label data from the target domain, we will look at active learning methods in that setting. So, in the first set of experiments, our goal was to identify which of these popular categories of methods work best when trying to adapt to these long tail domains in an unsupervised setting. Now, what does an unsupervised adaptation setting mean? It basically just means that you don't have any label data from the target domain, you just have some label data from the source domain and a lot of unlabeled sentences from the target domain. So you want to use the supervision from the source, but also the free text that you have available from the target domain in order to improve performance there. And in this scenario, feature augmentation methods can't exactly be applied because they basically work by breaking out the feature space into target specific and source specific spaces. And you can't really learn weights for the target specific space if you don't have label data in the target domain. So we essentially focus only on two categories of methods: loss augmentation and pre training. From the loss augmentation category, as I mentioned earlier, the method that we are primarily focusing on is adversarial domain adaptation. And this is a simple block diagram of what the method looks like. You have three submodules: the representation learner, which is responsible for learning representations for both your source and target domain instances; the task model, which is primarily responsible for predicting the task of interest, which in our case, as you will see next, is going to be named entity recognition and event extraction. And the third submodule is a domain classifier. And the goal of this module is, given some instance from either the source or target domain, predict whether it is from the source or target. And the way adversarial domain adaptation works is that you try to train the representation learner in such a way that it's bad at the task of domain classification, but good at the task of interest. And typically, this is achieved using a two-stage alternating optimization. In the first stage, you're training your adversary, which in this case is the domain classifier, on the task of identifying whether an instance comes from the source or target domain. And here you can use the unlabeled text that you have from the target domain. You don't really need any labels for the task of interest because you're just trying to predict whether this is from the source or the target domain. And the loss function that we use here is just usual cross entropy on domain classification. In the second step, what happens is you train both the representation learner and the task model modules jointly using this loss function shown on the slide, and I'll break it down for you. The first term in this loss function is essentially the loss on the task of interest, which is what you want the model to be really good at. So it could be either NER loss, cross entropy loss for NER, or cross entropy loss for event extraction. And the second term in this loss function is essentially the term that comes out of the domain classifier module. And you're subtracting this from the loss function. So you're basically trying to make the representation learner bad at this by making it have a higher loss on the domain classifier part. Sorry. In addition to the loss augmentation method, we also look at one method from the pre-training category. And in this category, the method that we use is continual pre-training, something which was proposed by Guru Rangan et al. In their ACL 2020 paper. And the way this method works is you first continue fine-tuning a large-scale language model on unlabeled text from the target domain. Then you follow it up with training for the task that you are interested in, which is, again, in our case, NER or an event extraction on labeled data from the source domain, followed by finally testing the model on data from the target domain. And as I mentioned earlier, we are trying to evaluate the performance of these methods in an adaptation setting. And the specific domains that we are looking at are transferring from news articles to clinical narratives. And again, the transfer is we're trying to do it in an unsupervised setting where we're not using label data from target domain. And as I mentioned, there are two tasks of interest. The first one is entity extraction or named entity recognition. And for this task, the data set that we are using from the source domain is Cornell 2003, which includes entities like persons, organizations, locations, etc. And the second task of interest for us is extracting events, which are actions, states, accomplishments, etc. And again, for the source domain, which is news articles, we are using Time Bank, which is another benchmark data set for events. For testing on the target domain, which right now is clinical narratives, there are three different data sets that we look at for entity extraction. Two of them, I2B2 2006 and 2014, focus on the task of PHI identification, where PHI is protected health information. And that includes things like patient names, hospital names, dates, things that you would want to scrub out from a record if you're trying to build a large scale data set in order to avoid inadvertently leaking patient details. And as you can see, these kinds of entities are broadly similar to the kinds of entities in the Cornell 2003 corpus because that also focuses on like persons, locations, organizations. So you can map the label space from these two data sets to Cornell 2003. And therefore, when we are evaluating model performance, we evaluate it on both span identification and type prediction. On the other hand, the I2B2 2010 dataset that we have focuses on the task of identifying medical entities, mainly of three different types: problems, tests, and treatments. And as you can see, these types don't really mesh with the Cornell 2003 entity types. So we can't really construct a label mapping between these two. And so most of the models that we evaluate on this method will primarily be evaluated only on identifying span boundaries and no type prediction. And the second task that we're looking at, which is event extraction, for that we use two different data sets, I2B to 2012 and empty samples. And these data sets are quite similar in the kinds of events that are present in them, with the exception of like two minor differences. The first one is that empty samples primarily focuses on single token events, whereas in I2B to 2012 you can have events that are multi-word spans. And the second difference is that I2B to 2012 treats certain categories like medications and locations also as events, but that is not true for the empty samples dataset, and it is also not true for the source domain dataset time bank, which we use for event extraction. And finally, the baseline task model, irrespective of any adaptation modifications that we use, is a BERT MLP based sequence labeling model. So basically, given a sentence, you compute token level representations for each word using the BERT language model, and then you use an MLP layer on top of it to predict labels for each of those tokens in the sequence. And note that in addition to evaluating the performance of loss augmentation and pre-training methods, we also tried to evaluate the performance of the model in a zero-shot setting. So you're just training it on the source domain and testing on target with no adaptation involved. And these are the results on the three different NER datasets. As you can see, loss augmentation does better than pre-training on all three, with an interesting result being observed for I2B2 2014, where we see that the zero shot model is actually doing better than any kind of adaptation method, or at least these two kinds of adaptation methods. But we'll touch on why this happens in the analysis later, which will give more insight. And for the event extraction task, we again saw similar trends with loss augmentation methods doing better than pre training on both the datasets that we were looking at. So we do not want to stop by just identifying which categories of methods are working better for clinical narratives, but we also wanted to see whether we can identify some relationship between the source and target domain that leads to certain categories of methods performing better. And one way of doing this is to perform a source target divergence analysis and correlate source target divergences with performance improvements or drops achieved by various adaptation methods. So the way this works is you just have a measure that gives you a score based on how different or similar your source and target domain data distributions are, and then you correlate these difference or similarity scores with the relative performance increases or drops you've observed with the adaptation methods that you're using. And of course, there isn't like one best way to measure difference between source and target domains. In fact, there are a lot of metrics that have been developed over the years of domain adaptation literature being evolving. And there's a recent survey paper at NACL last year, which gives a very detailed overview of what are the different source target divergence measures that have been proposed. And they broadly group them into three categories: geometric, information theoretic, and higher order measures. They also carried out a really large scale study looking at, I think, 130 different source target domain pairs and showed that information theoretic measures were really, really good at correlating with the potential performance gains or drops you see when moving from a specific source to a target domain pair. And so, for most of our experiments, we rely on term vocabulary overlap and information theoretic measures, which their experiments showed were the most predictive. So, what is term vocabulary overlap? The way term vocabulary overlap works is you just calculate what fraction of vocabulary from your target domain is also present in your source domain. It's a really simple metric. On the other hand, the information theoretic family of metrics has a bit more nuance. So, this includes measures like KL divergence, Jensen Shannon divergence, and Renyi divergence, which typically are used to measure distances between two probability distributions. So, how do you convert a domain into a probability distribution? We follow a really simple tactic of computing the probability of word usage in the source domain and the target domain. Of course, you need to filter out stop words first because stop words are pretty much very highly common across all domains. But for the remaining words, you compute the probabilities of their usage in the respective domains and then compute the divergence between these two probability measures, probability distributions. Just a quick overview of some properties of these distance measures so that the analysis is a bit clearer. Uh, TVO or term vocabulary overlap is an overlap metric while the remaining three are divergences. So, if two domains are highly distinct, you are likely to see low values for TVO and higher values for the remaining three divergence measures. And another important distinction between these sets of measures is that term vocabulary overlap only cares about how much vocabulary is common between the two domains that you're transferring across, while the remaining measures also care about how different is the usage of those words. Because TVO only looked at the proportion of shared vocabulary, whereas these three looked at difference in the probability of occurrence of those words. As I mentioned before, we did a correlation analysis where we correlate the values of distance between source and target domains under each of these metrics with the relative performance increase or drop you saw by adding this adaptation method, either loss augmentation or pre training, on top of a zero shot baseline. And these are the correlation scores. So, what does a positive correlation mean? If you have a positive correlation with with the term vocabulary overlap metric, that means you are seeing higher gains for domains which have higher overlap, which means they have a lot of shared vocabulary. And if you're seeing a positive correlation for any of the divergence measures, what that means is you're seeing higher gains for domain pairs that have more divergent usage of vocabulary, even if the words used are fairly common across the two. And for pre training, we didn't really get strong correlations under any of the measures, but for loss augmentation, we saw that it correlated very strongly with term vocabulary overlap and sort of moderately with the remaining measures. And this is indicative that loss augmentation basically relies on the existence of a large proportion of shared vocabulary between source and target domains, and it doesn't really care if the way they are used is different across domains. It just needs a lot of shared vocabulary. And in addition to doing this kind of a quantitative analysis, we also paired it with a qualitative strength weakness analysis, where strength examples are examples that only the particular adaptation method we are looking at gets right, while all the other methods get them wrong. And a weakness example is an example that only that adaptation method gets wrong, but everything else gets right. So, when we did this analysis, we had some interesting insights. The first one was that we saw both loss augmentation and pre training were good at handling technical vocabulary, which is one of the biggest challenges when you're moving to clinical narratives that are typically written by doctors and nurses and use really complex medical terminology. But this also has its downside, which relates back to the low performance that we saw in I2B2 2014, where, if you remember, the zero shot model was actually doing better than all other adaptation methods. And this downside is that, given short sentences with not much surrounding context, these methods have a tendency to overlabel medical terms as entities. So typically, in clinical records, there's a section where the doctor is doing a patient's regular checkup, and they usually have subheadings in that section like head, neck, arms, legs, indicating what parts the doctor actually did a checkup on. And the loss augmentation and pre-training methods ended up always labeling those kinds of terms as entities, which is not a good thing for I2B2 2014, because the entities there are not really medical, but instead personal information related to the patient, like patient names, addresses, dates, etc. And that is why we saw really low performance on I2B2 2014, because it had a really high proportion of these short utterances. The other difference that we saw between these two sets of methods was that loss augmentation methods were really agnostic to minor differences in orthography, which is like the way the words are written, whereas in pre training, we saw that it was really sensitive to odd capitalizations, something that's fairly common in headers and section headers and clinical narratives. So, at the end of this set of experiments, we sort of tentatively came to a conclusion that it seems like loss augmentation methods work better than pre training when we are trying to do unsupervised adaptation. And term vocabulary overlap seems to be strongly correlated or predictive of performance of the loss augmentation set of methods. And loss augmentation methods seem to be really effective with technical vocabulary, which opens up scope for them doing better on other high expertise domains as well, like biomedical text or financial text, etc. So, this is the space that we've covered so far, but we also decided to expand this set of experiments to more domains like clinical conversations. And in addition to expanding to an additional domain, we also tried looking at a stronger pre training method. So, if you recall in the previous set of experiments, the way we were pre training was we pre trained only on unlabeled text from the target domain, which is continual pre training. But the problem is that you're pre training your language model on the target domain and then using supervision from the source. But there might have been some level of catastrophic forgetting where its performance on language modeling on the source domain might not be as high anymore. So instead of doing that, we used the joint pre-training trick suggested by Hahn and Eisenstein, who saw that it actually helped in an unsupervised adaptation setting for sequence labeling tasks. So instead of fine tuning the language model only on the target domain, we are fine tuning it on both source and target, followed by task training on source domain and then testing on the target domain. And I'm not really digging into the details. If people are interested, I can go into that later. But even after this set of experiments, we saw that loss augmentation was still doing better on clinical narratives. But on the other hand, pre training started doing better on conversations. So this is the space of case studies that we've covered so far. But now we want to move a little bit, like switch gears a little bit and move from an unsupervised setting where we don't have any label data from the target domain to a limited supervision setting where you are allowed to use some data from the target domain. But if you can minimize how much label data you're using, that's sort of a win for you, because you have to spend less in collecting annotated data. And this is the scenario where we'll be exploring active learning methods. The reason why active learning methods make a really good fit for this setting is because the main goal of active learning is to make the models choose the data that they want to learn from. So, the idea is that if a model is allowed to pick what instances it thinks are most informative for itself, it might learn to reach better performance by having to look at fewer instances. And in this set of experiments, we focused on both clinical narratives and literary texts. So, the way active learning is used in a domain adaptation setting, I mean, there are multiple ways of doing it, but this is just the one that we experimented with. You first train a model on all of the labeled data that you have from your source domain. Then you have a bunch of unlabeled data from the target domain, and the goal is to use this source trained model to identify which instances from this target domain are going to be most informative for you. Once you get those instances, you get annotations for them, and then you further fine tune the source trained model. Then you reuse this fine tuned source train model to select a new batch of target domain instances. And this kind of a iterative procedure keeps continuing until you've exhausted the budget you have for collecting annotations in a real life setting. So, the baseline that we use for this active learning set of experiments is uncertainty sampling. And the key idea of uncertainty sampling based methods is that when you're choosing instances to learn from, you pick ones that the current model is most uncertain about. Now, what does uncertainty mean? Like, you can measure uncertainty of a model in many different ways, but for the set of experiments that I'll be presenting today, the measure of uncertainty that we used is token level entropy. So, token level entropy essentially just looks at how confused the model was across the different set of possible labels for all the tokens given a particular sentence or a particular sequence. And if a model achieves high entropy, or if the model probabilities lead to high entropy, what that means is the model is more confused about which label to pick for certain tokens in this sentence. And so it's highly uncertain, and that is the instance we should be picking for active learning. But there's one problem with using uncertainty sampling and just any kind of uncertainty measurement in general. Outliers are also instances that models are uncertain about because they are so different from the rest of the data. But picking outliers to label in active learning doesn't make a lot of sense, because you might learn to do well on those outliers, but you won't really learn to do well on the large proportion of your data set that doesn't really match those outliers. So, to avoid outlier selection when you're picking instances during active learning, the solution that we used is to incorporate representativeness as an additional criterion into uncertainty measurement. And this is a solution that prior work on event extraction and active learning has shown to be very useful. The way we measure representativeness is we embed all of the instances from the data set using a BERT or any kind of language model essentially. And for the current instance that we're looking at, you compute its average similarity to all of the other instances in this embedding space. And this representativeness criterion is then combined with the token entropy criterion as a weighted sum. So, our idea to improve active learning in this setting further was to incorporate domain awareness. Now, why does incorporating domain awareness make sense in this setting? So, you can think of this situation where you have two data sets. The blue points are all of the data instances from your source domain, while the red points are all of the instances from your target domain. Um, as you can see, there might be several instances from your target data set, such as the ones which fall on the WDS line here, that are very close to the source data set. And when you're doing active learning, you don't really want to pick these instances that are close enough to the source, because a model that has already been trained on the source data set is likely going to be producing accurate predictions for these instances, even if it's uncertain. So, in addition to the uncertainty sampling criterion, we wanted to design extra criteria that allow models to choose instances that are more central to the target data and more distant from the source data. And this is an idea that prior work has also explored, but what they did was they learned a classifier to separate out source and target domain instances, and then all of the instances that fell on the decision boundary of this classifier were considered to be ones that are really similar to the source domain and were removed entirely. But instead of doing this kind of a hard filtering, we decided to use or experiment with two soft criteria. The first one is using a classifier confidence based formulation. So the core idea here stays the same. You train a classifier to separate out the source and target domain instances. And then what you do is you compute a log odds ratio for every instance of its probability of belonging to the target domain. So instances that are more similar to the source data are going to have a lower log odds ratio, because the domain classifier is going to say that they have higher probabilities of belonging to the source domain. And therefore, if we multiply this criterion with any baseline criterion like uncertainty sampling, QBC, essentially any active learning criterion, what you would be doing is you would be upweighting instances that the domain classifier thinks are more likely to belong to the target domain, which is essentially what we want. The second formulation that we propose is a cosine similarity or an embedding similarity based formulation. And we decided to experiment with this because prior work has shown that if you embed a lot of different data sets in BERT and then do unsupervised clustering, they typically separate out by domain. So we decided to leverage this observation, and we did this by embedding all of the source dataset instances and target dataset instances using a language model like BERT. And then for every instance from the target domain, you compute its average similarity to all of the instances from the source domain data. And this tells you how similar your current target instance is to the source data in general. And because this is like a similarity to source metric, we divide the baseline active learning criterion with this because we want instances that are more dissimilar from the source domain. And so we use this as a downweighting criterion. And then for experimentation, as I mentioned earlier, we're looking at two domains, clinical narratives and literary texts. So for clinical narratives, we again use the I2B2 2012 event extraction dataset. And for literary texts, we use LitBank, which is a dataset of 18th century English literary texts from the Project Gutenberg website, annotated with events. So this is the performance for all of the active learning methods on the two data sets that we were looking at. And as you can see, these also note that this is the performance at the end of the final iteration. So we run 20 iterations of active learning where we select a batch, source annotations for it, and then further fine tune the source train model to rerun the process. But we noticed that even though there are really, really minor improvements on adding this domain awareness, especially by adding the cosine similarity formulation, we don't really think there's super high differences. You can see how close the bars are. So we decided to also look at the performance at every iteration in active learning, hoping that maybe in earlier iterations we see better performance, indicating that it's more data efficient. And to some extent, this is partly true on I2B2 2012. We see that the CS formulation is a little bit higher than the baseline, which is the blue graph. But random sampling appears to be really strong and equivalent to the best performing active learning method on both of these data sets. So we decided to also expand our set of experiments and look at NER datasets to see whether these observations held across a different task as well. And again, we're looking at clinical narratives, and here we're looking at the three datasets, the same set of three datasets that we looked at in the previous experiment, I2B to 2006, 10, and 14. Here we now start to see a bit more difference between method performance. So adding the cosine similarity formulation of domain awareness does seem to do much better than the uncertainty sampling baseline. But random sampling still seems to be extremely strong. And this observation holds even when we look at per iteration performance for entity extraction. As you can see, the gap between the uncertainty sampling baseline and the domain aware variance has started to increase, especially for 2006 and 10. And in the early iterations, it's really high sometimes. But you can see that random sampling is always equal in performance to the best performing active learning method that we were looking at. So we also wanted to perform a similar source target distance correlation analysis as we did in the previous experiment to see what are the domain pairs where adding this domain awareness criterion helps. And I'm just not re-digging into the definitions of TVO, KLD, JSD, and RD. I think we most likely remember them. Just to note that if we see strong negative correlations for term vocabulary overlap, this indicates that we are seeing higher performance gains for domains that have fewer overlapping vocabulary shared between them. And that is the case as we see with both the domain awareness formulations. They both have like fairly strong negative correlations with the term vocabulary overlap metric. So this indicates that this set of active learning methods is a nice foil to the previous set of unsupervised methods, because in unsupervised methods we were seeing higher gains with higher shared vocabulary, but here we are seeing higher gains when there's less shared vocabulary between the domains of interest. So, at the end of this set of studies, the conclusions that we came to were that adding domain awareness did seem to help active learning baselines on clinical and literary narratives in a transfer setting. But it seems like active learning in general was not a very successful set of methods. Nothing seemed to beat random sampling in all of the experiments that we conducted. And the term vocabulary overlap metric again correlated really strongly with performance. And this is just a meme to indicate that even if you run into negative results and when you're doing research or like proposing a new experiment, sometimes it's okay to produce a detailed tribute to why and how you were wrong, because it can sort of help uh, be a warning sign for later people that okay, this thing didn't work, so maybe we need to look at alternatives to this set of methods. Yeah, so this is the set of case studies that we've looked at so far. I have some more experiments which fill up the remaining blocks in this matrix, but in interest of time, I'm going to skip that right now. If people are interested, I can talk more about it later. There are some future directions that I see this work going into. The first one is In most of these analyses, we've been doing them in a retrospective manner. So we've been running a lot of adaptation methods and then trying to determine which ones work best on certain data sets. But I also want to look at the predictive utility of the observations that we were able to make from these studies. That is, say, given a new domain, we, based on all that we know about the theory of adaptation methods, pick certain adaptation methods as potential best performers. Does this help you achieve savings on various kinds of practical metrics like annotation budget, data collection, effort that you need to put in, GPU hours, data setup and model setup hours, etc. The other future direction that I'm really interested in is trying to expand the taxonomy and the experiments to new categories of transfer methods, because this keeps happening. Like every few years, there's a new paradigm in NLP, and we sort of need to switch all of the work that we've been doing to this new paradigm. And two categories of methods that I'm actually super interested in personally are retrieval augmented methods, where you might use information from a large scale text corpus or other external knowledge sources like knowledge bases, or even in a continual learning setting, information from domains that you've seen before. Retrieve them at test time or inference time when you're trying to do some prediction and incorporate them. The second category of methods that I'm really interested in are prompting based methods, where again you incorporate some kind of information about the source and target domain or divergence between the two domains into the prompt that you are feeding into the model. And finally, the last future direction that I'm really interested in is trying to build a standardized protocol and framework to assist doing these follow up and error analyses more easily so that they become more mainstream. And finally, what could be the broader impact of this kind of work? There are, because you might think that these domains are low resource, so why do we need to study them at all? But there are a lot of domains that are low resource but can have really high impact if you're able to extend language technologies, and specifically based on my work, information extractors to these domains. So, one project that we've been collaborating with the National Institutes of Health on is extracting and arranging key events that describe or affect a patient's physical and mental functioning, which affects whether they're able to work or not. On a timeline, and we expect these timelines to be really helpful for people who are trying to make policy decisions, like whether certain patients are eligible to receive benefits because they are too disabled to work. And trying to do this sort of a process, or like this sort of an automatic timeline construction process, can be really helpful in helping human adjudicators do the disability assignment or stipend assignment process much faster. So, this is just a thank you to all of my wonderful collaborators, without whom most of this research would not have been possible. And now I just want to take a brief detour and talk about the graduate admissions process. And I guess this is the part where a lot of you might have a lot of questions. So please feel free to ask me anything that you want to know. So, as most of you probably know, because this information is like very freely available online, there are four key components of your graduate application. The first one is a statement of purpose, letters of recommendation. The third one is demonstrating that you have competence in doing, like in your academics as well as in doing research. And this can come through a variety of sources like your CV, your publication record, GitHub repositories, your transcript, etc. And the last one is GRE and TOEFL scores. So they're ordered this way on the slide because this is the way I think they're ordered according to importance in the graduate process, in the like application process. GRE and TOEFL scores are typically given very little importance, so I'm not even going to cover them much, but I'll talk a little bit about the remaining three aspects. So, the first thing is a statement of purpose. And this is possibly the most important thing in your application, because this is what allows you to sort of tell your story and explain what you're looking for in a grad school program, what you would want to do when you go there, and sort of express why you think you would be a good fit for the particular program that you're applying to. This is just a link which gives a really interesting perspective and some general advice on what a statement of purpose should contain. But basically, just to summarize what this blog says, there are three main factors that you need to include in a statement of purpose. The first one being your qualifications, like what makes you ready to pursue this particular graduate program at this stage in your career or in your life. What is the preparation you've had so far? The second is your focus. So, if they admit you, what is the research area that you would want to be looking at? What are your future plans? Obviously, these are the focus part is something that you might not be super clear about, and it's always subject to change. I don't really think I ended up doing what I envisioned myself doing when I entered grad school. So, there's definitely a lot of room to grow and change your mind in this aspect. And the third one is fit, which is, I think, hardest for us to evaluate as people external to the department at the time that we are applying. And fit basically is sort of a way of demonstrating why that particular university or that particular grad program is a really, really good place for you to carry out your focus research. So, just a set of do's and don'ts, and a lot of these are a lot of these can change from person to person. So, uh, I think don't take them as the gospel truth, just take them as some helpful tips. In do's, I think one of the things that I really like telling people when I review SOPs for people, or even when I was writing my own statements of purpose and research statements these days, is that you need to include experiences which are most relevant to whatever you're applying to. So, say you're applying to PhD programs or master's programs and you're interested in doing NLP. You might have done a lot of projects as an undergrad in other research areas as well. Like you might have done projects in machine learning, computer vision, cryptography, what have you. But you don't really need to include all of that in your statement of purpose because you're already including your CV. So, people are going to look at your other projects and your other interests. The statement of purpose is a space for you to actually show that you're interested and aware of the area that you want to pursue in the future. So it has to be both retrospective and also forward looking. And that is why you need to identify the set of projects from your past experience that relate most to what you want to do in the future and only talk about those specifically. The second thing, and this is possibly the thing that you're going to get judged on the most, is identifying what you would like to work on during grad school. So there are two aspects to this. The first one that people will judge you for is how much depth and understanding of the overall field are you demonstrating. And you can accomplish this by making sure that the stuff that you write that you're interested in doing are problems that the overall field thinks are important, something that you can figure out by looking at what are the kinds of workshops that are appearing at conferences, what are the kinds of papers that are getting best paper awards, what are the papers that are getting a lot of citations in recent work. So what are the largest grants that you can see? Those can help you sort of identify what the field considers are broadly interesting questions, and then you can sort of try to develop instantiations of those questions, because you're obviously not going to solve a problem that the entire field considers is highly important during the course of a single PhD or a single master's program. So you need to sort of cut down and identify a chunk of work that's possibly feasible during a PhD duration. Again, as I said, this is also the part that's likely to change a lot. So just do your best at trying to sound like you have a broader perspective on the field. The second thing that people are going to judge you on is how well does your planned research or the area that you want to work on align with the interests of the advisors in the current in the school currently. So this is where it helps if you have people who are already at that same school or in that same grad program, because they can tell you who are the professors who are actively recruiting students, who are the professors who have openings for their projects, and you can try to align your research visions to these prospective openings. And the third point, which is identifying potential advisors and facets of the grad school program, you sort of relates back to the fit aspect, because you also want to convince the program that you're applying to that you would do well in the program, and you see that program as being instrumental in building your career or in taking the next step. So this is another thing that I think is really important. And again, if you possibly can get in touch with somebody who is at the same school, this can really help you improve your SOP, the angle that you take in your statement of purpose. The other thing that statements of purpose can be really good for are explaining unconventional things in your application. So this could include a lot of things. For example, you are doing your undergrad in a different area and you want to switch to an entirely different area in your grad school studies, you want to switch degrees entirely. Those kinds of things are really difficult for people to gauge based on objective things like your CV and your transcript. So you can really use your SOP to explain why your interests have changed and what have you done to alleviate this gap in your skills compared to somebody who would have taken the more conventional route. This is also a place where you can explain things like, maybe I did not really do well during coursework, but see, I have a set of really cool projects. So basically, anything that you think the hiring committee or like the grad school admissions committee could think is a problem, you can use your statement of purpose to sort of explain it better. And the last thing, and this I think is the most subjective point on the slide, is basically trying to build a compelling narrative. Because if you're just going to write a bullet list of your projects, then people are going to really get bored reading your SOP. So you need to try to build some kind of a story about yourself, like what made you interested in this area and where do you see yourself going further. Again, these are things that will probably change as you spend more and more time in the field, but even an attempt at trying to build a narrative shows some level of maturity that is really attractive to grad programs. And these are a set of don'ts which I've seen when I review a lot of statements of purpose. These are things I've seen people do, and I think they don't really work. So the first thing is sort of a counterpoint to the previous slide where I was saying that you only need to identify and emphasize a set of relevant experiences in your statement of purpose. Do not try to stuff all of your projects in the statement of purpose, because you're already including your CV and people are going to take a look at it. So it doesn't help you if you talk about 10 projects in your SOP but don't go into detail in any of them. It's much better to pick two or three projects that you think represent your overall interests and your plans for grad school and go really deep into them. Talk about why you did them, what excited you about them, what were your learnings from them. I'm sort of covering point three as well, I think. um, Cover all of the motivations surrounding the project and your learnings surrounding the project, and sort of give the other person the impression that you are able to conceptualize big research projects and carry them out on your own. The other thing is, don't try to stuff your statement of purpose with a lot of technical terminology. You should have enough technicalities in your SOP that you sound like somebody who has worked in the field for a bit. But really, the thing that matters more over sounding technical is being really clear about what you did and why you did it. So oftentimes what I see is people talk about, I built this model for this task, this and it got this kind of performance, and that's the end of the project description. But usually what committees are looking for is, why do you think the task was important in the first place? Why do you think the way you built the model was the best way to do it? And what did you learn at the end? Okay, your model did better on all of the experiments that you tried, or maybe it didn't do better, depends on the project. But at the end of the project, what was the big conclusion that you came to, which can sort of help you propose future projects or identify a research direction of interest? The fourth point, which is something a mistake I also made in my own statement of purpose, and I've seen in many statements of purposes, your SOP does not need to be chronological. You don't need to start by saying, oh, in my first year I did this, in my second year I did this, and then in my third year I did these bunch of projects, and now in my fourth year I'm doing this. That is not how your SOP needs to be structured. As I mentioned before, you need to have a forward looking aspect in your SOP. So you need to structure it in a way that you highlight the information that is most relevant to what you want to do in the future first, and then identify any other things that you think are relevant to your overall application in general. So you can talk about projects that you did in, say, your last year, because that is when you figured out what was the area you wanted to look at in the future. It's totally okay if you write your SOP in the reverse order, or if it's just in bits and pieces, some projects from your second and fourth years, and then some projects from your third year. The overall narrative is what guides the structure of the SOP. And the last point, again, avoid using lots of quotes or flowery language, because ultimately people want to see and read your thoughts about things, and people are reading tens or hundreds of these statements of purpose during admissions time. So the less you add these flowery distractions, the more likely it is that people are going to be really focused on the content of your SOP. And these are just some example SOPs that I think are particularly strong. There are two which are really NLP focused from Nelson Liu and Suchin Gururangan, who are PhD students at Stanford and UW respectively. And there's a really nice collection of statements of purpose on the third link. So if you guys are interested, you can just check these out. And the last point with respect to statements of purpose, definitely get at least somebody to review it. Again, a mistake that I've made in my prior applications. Get possibly try to get people who are in the same department to review it, because they can identify blind spots that you would totally not be aware of. This can include things like telling you about potential new faculty who are not yet listed on the website, telling you about faculty who are retiring or are just like going to emeritus status, not taking students for whatever reason, um, telling you about certain research areas that they know the department is focusing a lot more on, or is focusing on hiring new professors for in the current cycle. Those are the kinds of things that current students at departments are likely to give you really good and really insightful and helpful feedback on. And the thing is, BITS has a really strong alumni network. So you can probably find at least one BITSian almost at any good school in the US or in the UK or Canada, wherever you're looking for. And you can try reaching out to them. Cold emailing is okay, but just like be mindful of their time. Ask them if they have time to review your SOP. But even if you can't find somebody through these kinds of routes, there are many universities that have started providing application support programs, and CMU was one of them. We did a graduate application support program for 2 consecutive years, both in the 2020 cycle and in the 2021 cycle. So in these application support programs, you can typically upload your SOP and your CV and have current graduate students who are in the same programs that you're applying to give you really helpful feedback on your application materials. So if people are interested, I can give more details about CMU's GASP later. But there's a really detailed thread from the widening NLP workshop as well, which gives a list of all of these different kinds of application support programs that many universities have been conducting over the past 2 years, and you can visit that also for more details. Then the second most important component of your grad application process is going to be your letters of recommendation. So this is something that honestly you don't usually have a lot of control over, because you can only work with X number of people during your 4 years in undergrad. So the main thing that you should be focusing on is trying to get at least one letter from somebody who knows you really well and has advised you on at least one, preferably more than one research projects. Because when it comes to letters of recommendation, letters that focus only on highlighting your academic performance or your performance in courses, or from people who've only taught you, are often considered to be blank letters in the admissions process. So this is something that I did not know earlier, and I discovered when I was a student reviewer for applications this year. But a lot of times, if the letter is only talking about generic stuff like this person did my course and got an A, I thought this person was very attentive in class, etc., they don't hurt your application, but they also don't benefit your application. So they're just unnecessary pieces of additional evidence. So it's definitely necessary that you get at least one letter from someone who has advised you on a research project. The other two things that I would like to emphasize is, the first thing is, it's totally okay to communicate with your letter writers if there are specific points that you want them to put in the letter that they're writing for you. Like there's a specific project that you're really proud of, or if there's a publication you want to highlight, if there's some any other kind of achievement that you want them to mention. Maybe you presented it at some internal or external conference, anything of that sort. Usually, we feel hesitant in telling our letter writers what to write in the letter, but it's often okay to give them a set of bullet points, or just be like, these are the things I want you to definitely make sure that you mention. Of course, they're going to ultimately end up writing whatever they want, but if you give them a set of guidelines, it's usually useful. For them also, because they might even not remember a lot of the things that you've been doing, because they're advising a bunch of students, right? And the last thing is, you definitely need to communicate with your letter writers well in advance, at least a month and a half, and let them know that you're planning to apply to grad school. Let them know a tentative number and a tentative list if you already have it. That's usually helpful. And if you give them the list of grad schools, make sure that you're also including the submission dates for every university. And the reason I mentioned that it's helpful to give them enough advance notice is that advisors, this is the time of the year when advisors are usually the most overburdened because people are writing hundreds of letters for all of their advisees. So definitely make sure that you give them enough time to craft a strong letter for you. Otherwise, it's ultimately going to end up hurting your application. And also, definitely don't hesitate to follow up if you've noticed that the deadline has passed for a certain university, but your letter of recommendation has not been submitted yet. So it's totally okay in such scenarios to just email or ping your advisor or the person who's writing you the letter and remind them to just quickly do the submission. And finally, the third point, which was demonstrating academic or research competence. So, the first one, which is demonstrating academic competence, of course, the easiest way to do this if you have a high GPA, because GPA is often taken as a signal of the student's ability to be able to handle rigorous coursework, especially in universities like CMU, where coursework is a real pain sometimes. Um, but even if you don't have a high GPA, you can sort of supplement it, as I mentioned, either in the SOP or by showing that you had higher grades in the courses that are relevant to your major. So, say you're a computer science student, you can say that, okay, I had really high grades on the CS specific courses, even if I didn't on other stuff. The other direction that you can take, if and this is particularly for people who are switching directions, like moving from one field to to another, or even just switching research directions, is using GPA or your transcript as a way of showing that you've taken enough courses to have a basic understanding of the foundations for the field that you're applying for grad school in. And you can also, in addition to having them on your transcript, highlight them in your CV, bold them or list them separately so that they are emphasized when people are looking at your materials. You can also note this in your statement of purpose to make sure that you're demonstrating you have the technical chops to be able to deal with the coursework in whatever university you're applying to. And finally, the last point is demonstrating research competence. So, here the first point is something that I think a lot of people are under a mistaken impression these days. It's good if you have publications, it's always a plus. But people are also extremely understanding of the fact that as an undergrad who is just getting into the field and getting to learn about it, publication records are extremely hard to build. It's basically you don't really need to do a PhD before coming to join a PhD program, right? So people are extremely understanding of the fact that you can't have 4 or 5 papers by the time you leave as an undergrad student, especially 4 or 5 papers at top conferences like in NLP, it's ACL and EMNLP, and it could be different by field. It's more important to demonstrate that you've tried to do some research and you have some experience with it, and you've reached reasonable conclusions at the end of those research experiences. So that could just be like an open source GitHub repository, it could be just an archived report of what you did during the research project, or just even a really well written paragraph in your statement of purpose about what your learnings were from that experience. Um, Aside from that, the other thing is try to experience research via the traditional routes, which are like trying to do research internships, especially in your third year, trying to do research projects either at Pilani through our study oriented project possibilities and anything else. Try to see if you can find collaborations either at other institutes in India or other institutes abroad. Abroad, it's probably going to be a little more difficult because people get a lot of email and are very rarely likely to respond to you. And also, I think the most foundational experience, especially for me, was the thesis option that we have at Pilani. Getting to spend 6 months doing a thesis on only one topic is a really good way to just get into research and try to start figuring out what are the areas that you like. I think I learned much more from my PhD, from my undergrad thesis than I learned in any of my research internships as well, because that's one of the few times in your life where you get like a stretch of 6 to 7 or even longer. If you're a dual degree student, you can probably do a year long thesis. you get such a long stretch of time to focus on one or at most two problems, and that really helps you understand what PhD life is going to be like. And if you find it hard to get access to research experiences through like internships or projects, there, especially in the natural language processing community, there are a lot of really cool open research projects these days that anybody who has a reasonable amount of coding experience and an interest in natural language processing can try participating in. So the first one is an initiative that I'm also like part of, which is the Hugging Face Big Science Workshop, and they're basically trying to build really large language models in an open and transparent manner so that everybody has access to those. And like this workshop, I think, has about 500 people participating in it, and this includes people from all different stages, right from undergrads to really senior research scientists and professors in academia. And this is like this project covers such a broad range of research areas that I'm sure everybody will find something that they're super interested in. Aside from that, there are also projects like the NL Augmented project and the Natural Language Instructions project, where the work is essentially trying to contribute some new data augmentation methods or new prompting based methods for various natural language tasks. And these are sort of like NLP crowdsourcing projects, I guess is what I would call them. They're trying to get more and more people involved in NLP research by providing an open source platform for them to make their research contributions. And aside from all of these options, if you're open to the idea of trying something different before going to grad school, there are also pre-doctoral programs. Like I know that Google and Microsoft Research are particularly good ones. I'm not sure about other places, but these kinds of pre-doctoral programs can also be a really great precursor to grad school for the same reason that the thesis option is really helpful, because you get a really long stretch of time to focus on a small subset of problems, and it really helps you both experience what life in grad school might be like and also sort of start developing a taste for what kinds of research problems are most appealing to you but are also important to the community. And yeah, at this point, if you guys have any questions, I'm just going to stop screen sharing. Yeah. Okay, so I guess the first question is what motivated you to opt for a PhD and what are your future plans? Uh, okay, I have a strange answer to this. So, the reason I decided to go for a PhD was because I wanted to stay in academia and be a professor. But as I mentioned earlier, minds changed. So, that's no longer what I want to do anymore. Um, I think there are several reasons that people might want to get a PhD. Academia is definitely one, because if you want to stay in academia, you need to get a PhD. That's like a given. But oftentimes there are a lot of benefits to getting a PhD for even industry. Like if you ultimately want to end up making a career in industry, because there are certain kinds of positions, like research scientist positions, that are typically only open to or have a preference for PhD candidates. And I would say that so this is specifically for natural language processing, and maybe it's applicable to computer science in general. But industry research is also quite open these days. And in addition to being open, industry can also provide you a lot of resources. Like there's lots of data, lots of compute, there are lots of interesting problems. So, if you ultimately want to go to industry research, having a PhD can sometimes help you break into those more researchy kinds of roles. And in addition to that, having a PhD, if you are okay with like the financial implications and etc., for a couple of years in your life, it's also a really good time to learn about learning. So, one of the things that I feel PhD helped me do better, and I might not have gotten from possibly working in industry for this duration, is that I learned how to understand a research field on my own and figure out what things about it appeal most to me and what I would like to work on most and push the most. So, if you're doing an industry, I'm not saying it's not feasible. It's just that you won't have as much freedom to do it as you get in a PhD. Because in a PhD, you're only essentially answerable to your advisor and your source of funding, right? So, the amount of freedom you get to explore and to learn about yourself and identify what are the things that excite you most about a particular field, that experience is sort of unique to a PhD. So if that's what you want to experience, I would definitely say try to do a PhD. As for my future plans, I just defended yesterday, so I don't have I don't have things fully mapped out yet, but I'm planning to go into industry research and then after 4 or 5 years reconsider whether I want to come back to academia or continue staying in industry. Second question: how do you justify the break after graduation in the SOP? So I'm not sure what you mean by break. Do you mean break for personal reasons or break for professional reasons? Like, say, okay, I'll just answer it both ways. So the first thing is if you're taking a break for personal reasons, and could be anything, personal health, family health, any other kinds of issues, your SOP is definitely the best place to write about it. And I think you should try to. So when you write about your in your when you start writing your SOP in the first paragraph, I typically suggest people write what program they're applying to and why. So that is the point where you would start to like introduce why you took the break. You could say that over the past 2 3 years this is what was going on and this is why I decided to take a break, and I think that I am now in a much better position to start start pursuing a graduate degree. And then you can elaborate on it later in your SOP. It's up to you how much detail you want to give. If you're talking about a professional break, like you went for break for building profile, I don't think that's something that needs to be justified at all, because there are lots and lots of people who do PhDs or masters much later in life. So as an example, there's somebody in my group who started doing her PhD after working in JP Morgan for 10 years. So she's like a AI tech lead or something in JP Morgan, and she's now starting her PhD. So that is absolutely not unconventional. It's actually fairly common, especially here. People often value these kinds of breaks that you take because one, they help you just boost your credentials. As you said, your profile becomes much better. And second, it helps you reach a certain level of maturity both in your research and in like learning how to handle projects, carry them out and execute them. So I think that is yeah. So I think that's definitely not something that you need to justify per se in your SOP. You can always explain that you thought you did not have enough real world experience, so you wanted to get a taste of it and you went out to industry, or decided to get a pre-doctoral program or whatever else. Um, what is the next question? Did you find a mailing list? How did you find NLP opportunities? What sources do you recommend? Okay, so there's an NLP Slack. If you're specifically interested in NLP, I don't know about other sub areas of CS. There's an NLP Slack, which if people are interested in, I don't know, maybe I can send the link to the organizers and they can share it with you. So you can join that Slack and then like try to start making friends there, because there are in that Slack there are channels divided by areas of interest. There are channels for specifically undergrads, things like that. Another thing that I would really recommend is ACL's year-round mentorship program, which is also open to everybody. It's not really a research mentoring program, it's more about career building and professional development. But by joining that mentorship program, you can both learn from people who have been in the field for a while, as well as try to figure out who in your cohort is also interested in NLP. And oftentimes finding like-minded people who are at the same stage, like who are undergrads right now and are planning to apply to grad school, is really helpful, because they are going to become your future colleagues and your future collaborators. So I think those are two. I think I lost the question. Okay, but those are two things that I would definitely recommend. I'm not aware of any mailing lists per se, but I will look into this later. For computer vision, could you recommend some resources? I'm not super familiar with the field, I think, but I could try to find out and let you know. Do you recommend collaborating with your peer group for projects? Definitely. So I guess you mean within Pilani. I think one of the best benefits of being at Pilani, or essentially any university or college that is in the top maybe 10, 15 of the field in that particular region, is that you have access to peers who are way smarter than you on every axis, and people that you can really learn from. So if you have a chance to collaborate with people, you should definitely do that. How do you deal with rejection of
Yeah,
application?
that's a head up. It will end in 10 minutes.
Okay, thanks a lot. So how do you deal with rejection of application? Never gets easy, still happens. Rejection is something that you're always going to face in life. I don't think there's an easy way to deal with it. My way is okay, be sad for the day and then pick yourself up the next day. This reminds me of something really interesting. So, I don't know if you're aware of it, but there was a person who wrote up a CV of rejections. So, kind of like a typical academic CV, but he listed everything that he did not, like he applied to but did not get. And I was thinking about it at some point, and every line in a person's CV that you see usually hides at least 4 to 5 rejections. So, I think what you should do is give yourself time to grieve over it or feel bad about it, and then make sure that you pull yourself out of it and move on to the next opportunity, because there are a lot of rejections, but there are also a lot of opportunities, and you can always find something that will come along for you. I guess the best way is you can always catch the train at the next stop, right? You don't have to catch it right now. And then, could you share your journey with cold emails? Okay, I meant to cover this in the presentation, but I think it slipped my mind. So cold emailing is something that typically is frowned upon in computer science. Again, this varies very highly by research area, but usually most people in computer science are not super receptive to cold emails, primarily because this is such a growing field and people get so much email in their inbox. I'm not even a professor and I get a lot of cold emails. So I can sympathize with people who just have a barrage of emails waiting for them every day. What I would suggest with cold emailing is, if you're trying to do that, usually don't unless the professor has written on their website that they're open and receptive to receiving cold emails. Most professors have a section on their website the, describing their general reaction to receiving cold emails. Some people are really supportive. Some people tell you that no, I will not respond. Some people tell you that you can try emailing me, but I don't guarantee a response. Knowing that ahead of time is usually very helpful. If you are writing, if you like, if the person has indicated that they're receptive to receiving emails and you are writing one, you should always be very very detailed in your first email. Explain exactly why you are cold emailing them. What is it that you want? So if you say something vague like, could you help me with grad school applications, that's usually going to be like, I don't know what you want me to help you with. Instead, if you ask me something like, I was looking for somebody who is familiar with CMU's Language Technologies department to give me feedback on my SOP because I am applying to programs in that department. That is way more concrete. And then I know that you're expecting me to spend maybe 2 hours reading your recipe and giving you feedback. So people are way more likely to respond to those kinds of concrete emails as opposed to something that's vague. The second thing is always provide context. So your email should always begin with a 2 sentence introduction about who you are and why you're reaching out to them. And the third thing is, if you're reaching out to someone for collaborations or doing a project rather than just getting some advice. So, giving advice is like a very low effort task for somebody, right? Like, I could spend 1 or 2 hours talking to somebody and that's the end of it. But if you're reaching out to somebody for an internship, for a collaboration, for something that's potentially way more long term, um, you should always do a lot of research about that person and really make your case for why you think this collaboration or this project or this internship is not only going to be useful to you but also useful to them, because they have a lot of things going on. So taking you on as a potential advisee has to be something that they deem is worthy of, not worthy, I guess, they deem is useful for their time as well. So I would definitely say you should write your email in a way that makes it sound like you've learned enough and researched enough about them before you made the decision to reach out. Like it was a conscious choice rather than a mass email that you send to 100 different professors and is essentially a carbon copy of the same content. Then, do you recommend going after a hotshot professor or a better project? Always the better project. Many reasons for this. The first one being that earlier in your career, it's always better to learn more rather than work with big names because, uh, like, especially after the last 6 years, when I've been doing like my master's and PhD, one thing I've realized is people can be really famous but not be good mentors, and that matters a lot because you will have times when the project isn't going well, when you're really stuck, when you've lost motivation to work on it, or you might just want more hands-on technical advice. And oftentimes people who are really famous or a super ahead in their field are either in a position where they don't have the time to devote to their students, or they're very close to retirement and probably starting to plan out their future life and not really giving as much importance to their research work anymore. So I would always lean more towards the better project, both for the learning opportunities and for the mentorship opportunities that you will get from doing that. And over time, if you the thing is, if you work hard enough, you'll always be able to shine no matter where you are. So you definitely should always focus on improving your learning and getting a good mentor. And do you recommend going for a scholarship for MS plus PhD or just MS? I'm not sure I fully understood this question. So, do you mean are scholarships available for MS programs and MS plus PhD, and you want to choose which one to go, or are you asking me merits of MS plus PhD versus MS? I
Maybe
guess,
maybe we can get that clarified after the talk when we have the
yeah,
tables.
I think that's all the questions, right? Did I not answer something? Oh, did you take up thesis in your graduation? Yes, I did. What was your cold mailing schedule for research opportunities? Okay, for the cold mailing schedule part, typically try to get emails into people earlier in the week, preferably when it's morning time for them. Uh, During internships, I think I cold emailed only for DAD, which is like you need to do that because there are very few of us who already know somebody who is a professor in Germany. And the thing is, DART is a very centralized program, so people know to expect those kinds of cold emails. I did try cold emailing for my thesis as well, but that was way less successful. So I don't have good advice on that um, on that aspect. Could you share how to track Bitsians who are in grad school, especially like CMU, for contacting them, collaborating, advice, etc.? So one thing I think, and I don't know if it exists anymore, but there used to be this Yahoo group with a spreadsheet of Bitsians who were admitted to grad programs every year. I don't know if it's up to date anymore or um, if it's even maintained, but I think that's an initiative that it would be good if the CSA could think about taking, like maintaining a record of which CS alumni have moved where. Another place is, I think there's a Bitsians for Grad School Facebook group also, which is another place where you could like figure out who is where and also potentially reach out to them. I don't know if there's a centralized resource anywhere, unfortunately.
Sorry to cut in, but I think that's all the time we have today. We can continue with the questions at the tables. I'll just uh,
Okay.
your vote of thanks. Thank you, Akansha, for a wonderful session. The first part gave us a small taste of the current state of the art research in information extractors and the effects that the adaptations have. And I'm sure the grad school admissions advice were extremely helpful for a lot of us, including myself. The common pitfalls were pretty enlightening, and I'm sure I personally would be rewatching those parts when I'm preparing for my own applications. Thanks a lot. We can continue with the questions now in the tables. I'll be ending the session and we can join a table and we can continue questions. Thank you all for attending.